we're talking about exponential functions. So I'm going to go ahead and graph y equals 2 to the power x. Now, the graph is already shown for you. So let's go ahead and make a table. So you're going to say x, and then you're going to say y. And we're going to start with -4. I chose -4 because it starts here with -4, but you could have selected -5, -6, and so on. So -4 is the same thing as saying 2 to the -4 power, which is 1 over 2 to the 4th. And if you want to use your calculator, you can. Go to y equals 2 to the power x. And then go ahead and do the table. And you notice that -4, it's 0.0625. When x is -3, we have 2 to the power -3, which is 1 over 2 to the power 3, which is 0.125. -2, it's 2 to the power -2, which is 1 over 2 to the 4th. And we have, 1 over 2 to the 2nd power, which is 0.25. We have -1, 2 to the -1 is equal to 1/2, which is 0.5. 0, 2 to the 0 is equal to 1. Now, I do want you to continue with 1, 2, but you notice we have 2 to the power 2 gives you 4. We have 1, 2 to the power 1 gives you 2. And then 2, when x is 2, we have 2 to the power 2, which gives you 4. And I want you to notice the y values. As you see, it's increasing pretty fast. This is an example of an exponential growth model. And if we talk about domain, in other words, what are the possible x values? You notice it's from -infinity to +infinity, which means it's all real numbers. Now, I do want to introduce a word. This is called an asymptote, horizontal asymptote. It's horizontal asymptote, and it will never cross the x-axis, so the range will be y greater than 0. The next graph that we're gonna do is y equals 10 to the x. So go ahead and make a table. We have the x-axis and the y-axis. Now once again, we'll start with -4, and then we'll go to and so on until we get to 2. So I'm going to go ahead and clear the calculator. Go to y equals, go ahead and clear it. Now we have 10 to the power x. Go to the table, and we're going to start with -4. So we have 10 to the power -4, which is 1 over 10 to the 4th, which is 0.0001. -3, we have 10 to the power -3, which is going to be 1 over 10 to the 3rd, which is 0.001. -2, we have 10 raised to the -2 power, which is 1 over 10 squared, which is 0.01. And then -1, we have 10 to the -1 power, which is 1 over 10, which is 0.1. 1, we have 10 to the 1st, which is 10. 2, 10 to the 2nd, which is 10 squared, which is 100. 3, we have 10 to the 3rd, which is 1,000. The domain, once again, is all the possible x values, so it's going to be from -infinity to +infinity, or we say all reals. The range, once again, we have a horizontal We have a horizontal asymptote. It will never cross the x-axis. Horizontal asymptote will never cross the x-axis, so we have the range is y greater than 0. Okay, and this is also an exponential growth model. We're going to analyze both graphs, y equals 2 to the power x. Of course, we're going to use function notation. F of x is equal to 2 to the power x, and g of x is 10 to the power x. And we're going to see what's the max and min over the interval -2, 1. So what I recommend you do is go to the y equals. We already have 10 to the power x. Let's just focus on -2 to 1. So we're going to focus from -2 to 1. So let me highlight this. We're going from -2 to 1. We're going from -2 to 1, and we're also focusing on the y values. So that's why I'm highlighting. We're going to focus on the x, and we're going to focus on the y. Okay. So what you need to do is you need to make a table. And we have 10 to the power x, and we're just going to focus on from -2. We know that when -2, y is 0.01. When x is -1, y is 0.1. When x is 0, we know that y is 1. When x is 1, we know that y is 10. So we can stop. And what do we notice? We notice that at x equal -2, 0.01, that is our min, and our max is at 1, 10. So let me write that down. So this is our min. This is our min, and there's our max. And where do you see that on the graph? You see that right here. That's -2. 0.01. Where do you see your max? 1, 10. So you see your max and you see your min. So now you're gonna go ahead and do the same thing for y equals 2 to the power x. You're going to create a table, and we have x and we have y, and we're going to start with -2 and then work ourselves all the way to 1. So let's go ahead and use a calculator. So it's no longer 10, it's 2 to the power x. And we're going to go ahead and start at -2. Since that's where the interval starts, -2. So it's 0.25. When x is -1, it's 0.5. When x is 0, it's 1. When x is 1, is 2. And once again, I'm going to highlight. When x is -2, it's 0.25. When x is 1, y is 2. So let's go ahead and graph that. So this is right here. So we have 1, 1, 2, which you know that's going to be your max. And then we have this point, -2.25, that is your min. Modeling exponential growth, there is a formula that they're sharing there with you. It's right here. This is the formula, and we're going to be utilizing that. It says you invested 1,000 in savings account at the end of 6th grade. The account pays 5% interest. How much money will you account after 6 years? You've invested $1,000. You know that the account pays 5% in interest, and you want to figure out how much is it after 6 years. So you're going to use the formula. A of t is equal to A. Now A stands for the money you started with, 1 plus the rate. Now the rate has to be in decimal form, 0.05%. And then T stands for time. So let's go ahead and write that down. So we have A of, now you said 6 years. And we have, we started with 1,000. 1 plus, if you forgot how to convert rate into decimal, it's going to be 5 over 100. And then it's raised to the 6th power because that's the years. So every number has a meaning. We have 1,000, which is going to be how much money you started with. The 6 represents the years, and then 5 over 100 is the percentage. So you can come over here to your graphing calculator, and you have 1,000 parentheses 1 plus 5 divided by 100 raised to the 6th power. So it's 1,000 parentheses 1 plus 5 divided by 100 raised to the 6th power. And after 6 years, the amount of money that's going to be in the account is $1,340.10. Okay, I rounded off to the nearest cent. So you've earned an interest. If you subtract, you've earned an interest. Oh, my mistake. I subtracted 100. So you've earned $340 in interest. How did I get that? 1,340.10 minus 1,000. And that's $340.10. In this example, what I did with the class, I just explained how to solve it. There was nothing to be writing. So it says use exponential growth. Suppose that you invest 1,000 in the savings account that pays 5% interest. If you make no additional deposits or withdrawals, how many years will it take for your account to grow to at least 1,500? Okay. So what I'm going to do is I'm going to type in my equation. I know it's 1,000 parentheses 1 plus, and I'm using this right here, 0.05, and then it's raised to the x. Why is it raised to the x? Because that's going to be changing. The years is going to be changing. So if I look at my table, we're going to start with 0, and 0 tells you there's $1,000 invested. Okay, we got to figure out when it's going to reach, when is the y value going to reach 1,500? So you just have to scroll, and you notice after the 9th year, it's $1,551. Okay, so it looks like you have to wait 9 years. You won't be touching it, withdrawing or depositing. After 9 years, you're going to earn $551 in interest. And so that's the answer to the question.